Okay, question 10. The following sequence of transformations is applied to the curve y equals 4x squared. So we have a translation, we have a reflection, and then lastly we have a stretch. Okay, what is the equation of the resulting curve? So this is testing how good you know transformations. Yeah, and by the way, the order of the transformations actually matter. Yeah, I mean, I'm going to give you a classic example maybe later in the video, but let's do the question first. Yeah, just to warn you that the order matters. So don't do 3 before 1, for example. Yeah, you start from 1, 2, and then 3. Okay, so translation by 3 minus 5. So translation by 3 means that you move to the right by 3, right? Moving to the right by 3 means that now you're x minus 3, right? So x minus 3 squared. Yeah, oh well. Okay, translation by minus 5. So you're going down by 5, yeah, down by 5, so like that. Yeah, so far so good. Reflection of the x-axis, what does that mean? That means that you flip the y basically, right? So y equals minus whole chunk. Yeah, make sure to take the whole chunk. Yeah, make sure you take the whole chunk, please. Like that. Yeah, reflection of the x-axis is, normally if y equals fx, then the reflection of the x-axis is y equals negative fx, right? That's why it's negative of the whole thing. Yeah? Okay, lastly, stretch parallel to the x-axis with scale factor 2. That means that the x becomes x over 2, right? So y equals negative 4 times x over 2 minus 3 squared minus 5. Okay, so now it's just a expansion exercise, to be honest. So this is, okay, let me be careful here. So x, well, let's multiply the 4 inside, shall we? So when we multiply the 4 inside, just make sure you're careful, yeah, because there's a square there. So basically, if you take the 4 inside, it becomes a 2, right? Because 4 is 2 squared, yeah? So this is negative x minus 6 squared now, yeah? Plus 5. I hope that makes sense, when the 4 goes in, because the bracket is a square, yeah? So every bracket gets a factor of 2 instead of 4, yeah? Okay, so this is negative x squared plus 12x minus 36 plus 5, which is minus 31. Okay, so the answer seems like it's A. Yeah? It seems like it's A. Okay, so the example that I could give to show you that the order matters is this. Yeah? So imagine if you have two things, like for example, well, let's just take the example in the question, to be honest. Let's say translation to the right by 3. Yeah, and then second guy is the stretch. Yeah, let's say stretch. Let's do a shrink instead, just to make things a bit different. So let's say shrink. Yeah, parallel to x-axis, scale factor 2. Yeah. So if I do this in this order, yeah, then what do I get? I get f of 2x minus 3 at the end. Yeah, 2x minus 3. But if I swap the order, yeah, if I do the shrink first and then translate to the right by 3, then it's a different story, yeah? Then it's a different story. If I swap the order, it becomes f of 2 brackets x minus 3. Yeah, so make sure you're careful. Yeah, if you swap the order. Yeah, if you swap the order, it becomes the guy down below. Yeah, have a think about this. It's a bit counterintuitive in some way. Yeah. So if both of the transformations are x-related or both of them are y-related, then the order matters, right? Then the order matters. But if one of them is x-related but the other guy is y-related, then the order actually doesn't matter. Yeah. For example, if it's a translation by 3 and a minus 5, you can do the minus 5 before the 3 if you like, yeah? Or you could do the 3 before the minus 5, because 3 is about the x, yeah, whereas minus 5 is about the y. Yeah, so just pay attention to the order sometimes.